oxide on the nanostructured coating, thicker, more continuous alpha alumina layer, very few mixed oxide regions. For the conventional counterpart, it had dual layer consisting of alpha alumina as well as the mixed oxide, and its overall thickness seemed lower. Typically, the TGO layer gets to a certain thickness and then you have failure. But it was obviously for the conventional coating, the layer was pretty thin before you had spallation, so that's not very good. Excuse me. The potential application for this bond coat work is that the Navy is already building the next generation electric boat. And what we heard is that they want gas turbine engines in there that are going to operate in 3 regimes: type 1, type 2 hot corrosion, as well as high temperature oxidation. And that has never been done before. But that's what they're setting out to do. As far as I understand, I believe GE won the contract, so I guess that's GE's problem. But we'd like to think that maybe this work may in some way contribute to addressing these issues. So I'm going to summarize the talk. Basically, thermal spray nanostructured coatings have been successfully incorporated into real military industrial applications. And we believe that it's got real promise for many other applications. Not for all. You don't need it for everything. But there are severe applications where there aren't solutions right now. And we believe this may be able to address that. I'd like to acknowledge contributions from Dr. Kavikoff at ONR, Warren Nelson, and Dennis Ray at GD, Mathieu Crochou and Jason Milligan at the University, Ricky Lavernia at UC Davis, as well as Don Wilson at UCLA. Thank you very much.
So we can take some questions.
So in the second slide, you mentioned about the applications for the non-military. What's the major difference on the thermal spray between the non-military and military?
Thermal spray, well, in the military application, they were using plasma spray. And that worked well. For our application, Gardner came up with a better way of applying it. So that, I think I mentioned the characteristics that we didn't have a laminar structure and we didn't form vertical microcracks. I can't tell you what the exact process is. It's proprietary, but you saw the end result was that the coating itself fared much better, even better than the plasma spray systems that were used within the military.
So basically, the military application is more stronger than industry and civil.
No, we're doing the same thing as the Navy did, except we think we've improved on it by changing the way we apply the code.
Can you go over here, please?
Go ahead.
Do you see a future as far as when you're doing the scratch tests and things like that, self-repairing in the future as far as the nanotechnology?
That would be more
programmable,
maybe, but it would be specific to the material. Like if the material, you find material that is, self-repair. Sometimes for high temperature silica can be material like that. But I don't think the nano necessarily, it could help accelerate the self-repair, but I don't think nano itself would make a non-self-repairable material self-repair. Yeah. I don't think so.
Question? Side question, actually, there may be some other technical questions. What inspired you to start your own company? What kind of things what inspired you to start your own company, and what kind of things have you really had to do in the course of developing this company?
Right. Actually, I always thought while I was in grad student studies and even in undergrad, a friend of mine and I always thought it would be kind of neat to be able to work out of the house or have your own company consulting. Originally, I wanted to go into corrosion. I live in Montreal. I see corrosion everywhere. I'm going to make an impact there. However, the decision to go after only being working for 5 years was not something that was really planned. As you know, originally I was supposed to go to the Canadian Space Agency. I worked there for a couple months. The circumstances was such that the Canadian Space Agency had to drop my contract. So, you know, it kind of ended up that I found myself in the position of starting my own thing, just because of circumstances. And as I mentioned, you gave me a contract initially, it kept me going for long enough until FW Gardner and Lucas came aboard, and then we were able to pursue that. And I guess the key is, you know, other than the help that you've, you know, in the beginning of my career, you know, Professor Ferrero took me everywhere around Houston, in Texas. We went to San Antonio Air Force Base, we went to Johnson Space Center, and it was really great. And that's the key for me, was you need to make contacts, right? And when you do make contacts, you know, you have to be willing to do some things at no cost. I mean, if you keep asking for money up front, you're nobody. There's not many people I know, especially in this economy, who's going to do that. So initially, just like with the Navy, you know, it didn't work for no cost, just to demonstrate. I mean, if you're going to convince the U.S. Navy to send money to Canada, you better show them that you got something fairly unique. So that's, you know, that's basically what I do. If it's a fairly substantial client, I will do some work to demonstrate the capability. And then, you know, usually if you do a good enough job, you'll start getting paid contracts. And then in addition, you can't just strictly do paid work, right? Because science is moving at such a fast pace. So I do a lot of work in collaboration. No one pays anybody. So right now I do collaborative work with the Army, where we produce metal powder, send it to them, they'll spray it, we share all the results, we co-publish. And that's been really integral in keeping in the front of the technology change in this area. And being a small company, it's helped in the sense that, you know, Congress has diminished, decreased some of the funding for research. Military research, however, being a company where, you know, getting a contract, $50,000 can be substantial, you can survive the lead periods. In fact, you can sometimes flourish in the lead period. I mean, people can, you know, do things like that. A lot of folks won't open a file for, you know, $10,000, $15,000. So, you know, all those things. I just count myself.
Gary, you have a question?
I have a question not related to any technical. Why you locate your company in Canada? Because of there is a better place to commercialize your technology, or there the environment is better than America?
No. Actually, the attorney asked me why I don't live in Texas. But no, you know, that's where I did. My parents brought me there. I grew up there, went to school there. My wife, I mean, that's the thing. I would move to the Bahamas. But no, my wife works there, and she's a lawyer, and so she's the boss.
Okay, other questions?
And what's the bounding force between all those nano powders?
You know, in theory, we know it's mostly mechanical, but in the ceramics